Jeff Lang, Managing Director of Titomic, here at Formex in Frankfurt 2019, the world's largest 3D printing show. So take a walk first. We're going to have a look over at our rocket that we've built, which is the world's largest titanium 3D printed part ever made. It's actually 5.5 meters high and made with the Titomic kinetic fusion process. So follow me over and we'll have a bit more deeper chat. So Titomic has talked about the large-scale, industrial-scale 3D printing that we can do. And we've finally been able to validate a product that really shows the capability, scale and size of what we can do in the rocket, such as we have behind us. Now this is produced out of titanium and it's actually 5.5 meters high, but more importantly it's validation of a company we're working with called Gilmore Space Technologies out of Australia, who eventually over the next year or so are going to build a 27 meter high rocket and using this capability and technology. The importance of this technology is not just how we can build a large scale rocket with additive manufacturing, but more importantly about the productivity and affordability that we can now use digital manufacturing technology to build rockets. So if you draw some comparisons against traditional manufacturing processes and even some of the more commercial space applications now being done by SpaceX and other companies, they moved away from titanium because it's been cost prohibitive to produce rockets with that process. It doesn't necessitate it's not the best material to use. It actually is. It has far better mechanical properties than stainless steel, such as stainless steel 301 that SpaceX uses. But more importantly, titanium is half the weight of stainless steel. So when we're talking about rockets delivering satellites and other payloads into space, it's important to understand the lesser weight involved with the rocket, the more payload that can be delivered into space. So we combine these elements as far as Titomic kinetic fusion capability to produce rockets faster than anyone else. This rocket was produced in an amazing 27.6 hours of actually time on our machine and then to put together as well. So it's quite significant just how quickly this rocket was to produce and the cost to produce that as well. So when we consider moving forward, if we look at the 27 meter rocket, we've estimated the time around that is around 165 hours on our TCAF 9000 to build that rocket. By equivalent to some of the older sort of Apollo missions and years that they took to build rockets, we're really at the advent of the future now as far as how quickly we can build parts based on additive manufacturing technology and more importantly, showcasing how Titomic kinetic fusion is the world leader in large scale additive manufacturing.